Good morning to everyone. Good morning. Okay. So what we will do is we have done already with some of the reactions, right? So that is related to chemical properties of group 17 elements. Then we have discussed about interhalogen compounds. So we have discussed about interhalogen compounds. Now when it comes to interhalogen compounds, so where we have the general formula as X prime, anything. Only thing is to indicate that both should be of different element, right? So when it comes to X prime, right? So that's where we have the electropositive with respect to or in comparison to X prime. I am telling. I am not telling that halogens are electropositive. No. Okay. And this will be electronegative. So once again I will tell. So electropositive means doesn't mean that halogens are electropositive compared to X prime. They are electropositive, right? So this is electronegative. Or to avoid, I can write it as less electronegative. Less electronegative. That's what we have seen with respect to interhalogen compounds. Now, when it comes to reaction, one of the reaction here is hydrolysis of interhalogen compound. Now, all of us we know less electronegative, that is X, will be released as HOX, and which is electronegative, that will be released as HX. So that's what with respect to hydrolysis of interhalogen compound. Fine. So then we have discussed about hybridization. Then we have discussed about the hybridization related to interhalogen compound, right? So that's whatever I am discussing is whatever we have discussed in the Saturday's class. Okay, so that's what I am discussing now. Now next we have discussed this with respect to geometric shape and hybridization. Geometric shape and hybridization, right? So that's what we had discussed. Now if I take IF7 as an example, and I told IF7 is the one which will be quite stable compared to all the other interhalogen heptahalides. That's where we have the IF7. Now when it comes to IF7, can any one of you tell me what was the geometric shape? So it will be pentagonal bipyramid. Pentagonal bipyramid structure. Right? So what will be the hybridization? Total 7 covalent bond. There is no leftover lone pair of electron on iodine. So that's where we have sp3 d3. 3 plus 3 6. Another one 7. So that's where we have the hybridization. Yes, someone had already written. So sp3. Yes, Sanjana. sp3 d3 hybridization. If I take IF5, so now naturally one lone pair of electron will be left over on iodine. So which was the shape? One lone pair of electron will be left over. What was the shape? Geometric shape of the molecule. Right? So that's where we have right? So that's where we have the square pyramid, right? So it will not show the bipyramid, it will be square pyramid due to the electronegative property of the fluorine. So yes, Bharat, it will show the square pyramid type of geometry. Then we have discussed about IF3. So two lone pairs of electron Two lone pairs of electron will be left over. I of 3. Any one of you. It will be bent T-shaped structure. It will be having bent T-shaped structure. So that's where we have the I of 3. So what is the hybridization in I of 5? I of 5. So 5 covalent bond, but 2 lone pair of electron. Therefore it should be sp3d2. Right? Now when it comes to I of 3, it will be sp3d hybridization. Because in case of I of 3, we have 3 covalent bond. So we have the 3 covalent bond, and how many lone pairs of electron? So 2 lone pairs of electron. That's where we have the sp3 dehybridization with bent T-shaped structure. Fine. So these are some of the important interhalogen compound. That's what we have discussed in the Saturday's class. Fine. So now when it comes to oxo acids of halogens, now, what do you mean by oxo acids? Oxo acids are those which will be donating the H plus due to the cleavage of OH bond, right? So that's where we have the oxo acids of halogen. And when it comes to fluorine, it will form only one type of oxo acids of halogen, that is, any one of you, that is hypofluorous acid, HOF. But when it comes to chlorine, it can show HOCl, HOClO, HOClO2, then HOClO3. Like that, it can show the different oxo acids. So chlorine is the one which will show highest varieties of oxo acids. Fine. Now that's where we have the hypochlorous acid. So now this will be hypochlorous acid is done. Now what will be this one? This will be simply chlorous acid. It will be simply called as chlorous acid. What about this one? This will be called as chloric acid. This will be called as chloric acid. And the last one will be perchloric acid. Last one will be perchloric acid. Once they have asked about geometric shape, once they have asked about which particular acid I have forgotten, they have asked about to write the structure of this particular acid, any one of these. Okay, so that's where you should be remembering that OH linkage should be there. Since we are talking about oxo acids, then you should satisfy the chlorine. Fine. So that's where we have the 3 oxygen. We have the 3 oxygen. So 1, 2, 3, 4, 5, 6, 7. So chlorine is also happy. Oxygen is also happy. Same way when it comes to chloric acid. So that's where 2 oxygen will be there. Now we have to satisfy the oxygen along with the chlorine. Now since both of them will be left over with 1 electron, therefore they will make the double bond with chlorine. Naturally 1, 2, 3, 4, 5, 6, 7. So 1 lone pair of electron will be left over on the chlorine. If you show the lone pair of electron, no problem. If you don't show the lone pair of electron, then also no problem. But linkage should be there. Proper linkage should be shown. Fine. So that's where we have the chloric acid. Then we have the chlorous acid. So once again, we should write these things. Then only 1 oxygen, so it will make the double bond. So how many lone pair of electron? 1, 2, 3, 4, 5, 6, 7. So 2 lone pairs of electron will be left over on chlorine. Fine. So that's where we have the chlorous acid. So these are some of the important concepts which we have discussed with respect to group 17 elements. All of you have understood? Fine. So that's what we have discussed with respect to group 17 elements. Okay. Okay. Video is paused, but here it looks fine.